Welcome to the Dragon 9 Media Podcast. This podcast is the first in a series focused on learning about artificial intelligence. If you enjoy this content, please subscribe and like this channel to help promote it to others. Our goal today is simple: to demystify the fascinating world of artificial intelligence, or AI. Think of this as your first step on an exciting journey. We're going to strip away some of the confusing tech talk and build a solid foundation of understanding piece by piece. You've probably heard a lot about AI. It's in your smartphones, it powers your search engines, and it's behind those sometimes surprisingly good movie recommendations. It's not science fiction anymore. It's a powerful technology that's already part of our daily lives and is set to become even more influential. So let's get started by demystifying some of these core ideas. What exactly is artificial intelligence? At its heart, artificial intelligence is about creating computers and machines that can perform tasks that typically require human intelligence. This includes abilities like learning from experience, understanding language, recognizing objects and images, making decisions, and solving problems. Think of it as a set of technologies that enable computers to do some pretty advanced things, like seeing, understanding, and translating language, analyzing data, and making recommendations. Now, it's important to know that the AI we have today is what we call artificial narrow intelligence, ANI, or weak AI. This means it's designed and trained for a specific task or a narrow range of tasks. For example, an AI that's brilliant at playing chess can't drive a car or compose music. Your smart assistants like Siri and Alexa are also examples of narrow AI. It's crucial to understand this because current AI excels at specific tasks, not general sentient intelligence like you see in the movies. The idea of an AI with human-like cognitive abilities, called artificial general intelligence, AGI, is still theoretical and a long-term research goal. So, with that baseline, let's dive into the real building blocks you need to understand. Building block 1, machine learning, MLs. First up is machine learning, or ML. This is a really core concept. Think of ML as a way for computers to learn without being explicitly programmed for every single task. Instead of a developer writing specific instructions for every possible scenario, they feed the computer lots of data. Special programs called algorithms then help the computer find patterns and learn from that data to make predictions or decisions. A great analogy is teaching a child by showing examples rather than writing out every single rule for every situation. For instance, you show a child many pictures of cats, and eventually, they learn to recognize a cat, even if it's a breed they haven't seen before. ML works in a similar way with data. It's the foundation for many AI applications, from predictive analytics and customer recommendations to fraud detection. There are a few main ways machines learn. Supervised learning. This is like learning with a teacher or labeled data. The AI is given data that already has the answers, labels, and it learns to make predictions based on that. For example, classifying emails as spam or not spam based on past examples. Unsupervised learning. Here, the AI gets unlabeled data and has to find patterns and structures on its own. Think of it like asking the AI to sort a mixed bag of fruit into groups without telling it what the fruits are. An example is customer segmentation based on purchasing behavior. Reinforcement learning. This is learning through trial and error by receiving rewards or penalties for actions. Imagine training a dog with treats for good behavior. That's reinforcement. This is how AI can be trained to play a game, for example. Building block 2, neural networks, and NN. Next, let's talk about neural networks, often abbreviated as NN. These are computing systems inspired by the biological neural networks that make up animal brains, including ours. They consist of interconnected neurons, which are small processing units that work together to process information, recognize patterns, and make decisions. An analogy I like is to think of a team of specialized workers passing information along an assembly line. Each worker, or neuron, does a small part of the job, and by passing their work along, the team collectively achieves a complex outcome. Neural networks are the backbone of deep learning, which we'll get to in a moment. Building block 3, deep learning, DL. This brings us to deep learning, or DL. Deep learning is a more advanced and powerful type of machine learning that uses those neural networks we just talked about, specifically neural networks with many layers, hence the term deep. Because they have many layers, these networks can learn to identify very complex patterns from vast amounts of data. Think of it like this. If a regular neural network is an assembly line, a deep learning network is like a highly specialized factory with many assembly lines and levels of expertise, capable of learning very subtle patterns. Deep learning is behind many of the recent breakthroughs in AI, especially in areas like advanced image recognition and understanding natural language. It's particularly good at handling complex tasks with high accuracy. Building block 4, Natural Language Processing, NLP. Now, let's look at how AI interacts with us. Natural language processing, or NLP, is the area of AI that focuses on enabling computers to understand, interpret, and generate human language, both written and spoken. The analogy here is teaching a computer to understand and speak human languages, much like a human learns a new language. It's what allows you to talk to your smart assistant like Siri or Google Assistant, get translations from an app, or see spam emails filtered out. Chatbots are another common example. Building block 5, Computer Vision, CV. And if NLP is about language, computer vision, CV, is about sight. This field of AI enables computers to see and interpret visual information from the world, such as images and videos. You can think of it as giving computers eyes and the ability to make sense of what they see. Core tasks include image recognition, like identifying objects in a picture, and object detection, locating objects within an image. This is the technology behind things like facial recognition on your phone or in security systems. How do these building blocks fit together? It's really important to understand that these concepts aren't isolated. They build on each other. Machine learning is the broad field, the overall idea of systems learning from data. Neural networks represent a specific set of techniques within machine learning inspired by the brain. Deep learning is then a subfield of neural networks, characterized by its deep layers and its power to handle complex data. It's what has unlocked many recent AI breakthroughs. Fields like natural language processing and computer vision often use machine learning, neural networks, and especially deep learning techniques to achieve their goals. For example, deep learning has dramatically improved how computers can understand images in computer vision or process text in NLP. The progression from machine learning to deep learning basically signifies an increasing ability of AI to handle more complexity and learn in ways that are more similar to how humans learn. Why does understanding these blocks matter for you? So, why are we going through all this? Because understanding these foundational AI principles provides you with the conceptual tools necessary for informed participation in discussions about AI. It helps you move beyond just hearing buzzwords to actually grasping the capabilities and limitations of different AI approaches. In today's world, understanding AI is becoming as important as understanding how the internet works was a few decades ago. Your journey has just begun. What we've covered today are the fundamental building blocks. This is your starting point. The field of AI is incredibly dynamic and evolving at a breathtaking pace. New discoveries, applications, and even ethical questions emerge constantly. So, I encourage you to stay curious, to keep exploring. Think of this as the first class in an ongoing course. As AI continues to develop, its influence on our careers, society, and daily routines will only grow. I hope this has helped demystify some of the core components of AI. Keep learning, and I'll see you next time. Thank you for watching. If you enjoyed this content, please subscribe and click the like button to help promote it to others. Our plan is to create many different learning tracks with podcasts, articles, and other supporting materials to support your learning journey.